Study what is graphing quadratic functions. So y equals ax squared plus bx plus c. So that is a formula for the graphing quadratic functions. So quadratic functions definition. So here are definitions of quadratic functions. Quadratic functions is a nonlinear function with a degree of 2. So the standard form is negative y equals ax squared plus bx plus c, where a is equal to 0. So the graph of quadratics. So the graph of quadratic function is a parabola. So the parabola is can open up or down. The turn point is called the vertex. So if the parabola open up, the vertex is the lowest point and called the minimum. So if the parabola is open down, the vertex is the highest point and called is minimum. So that you can see the vertex, the graph is the blue is vertex and down is minimum. So a graph of quadratics. So y equals ax squared plus bx plus c. So the parabolas will open up when the a value is positive. So the parabola will open down when value is a negative. So the parabola will be open the we when a value is a positive. So a value is positive, so that is a red. So the parabola will be open down when a value is negative, so that is a be down. So a value is negative. So the graph of quadratics is parabolas have a symmetric property to them. So we call this line the lane of symmetry. So if we drew a line down the middle of the parabola, we could fold the parabolas in half. So in half. So or if we graph one side of the parabola, we could fold or reflect it over. So the lane of symmetry to graph the other side. So the lane of symmetry always pass through the vertex. So you can see the lane of symmetry. So uh, so graphs of quadratics. So the y-intercept is where the parabolas will cross the axis. So plug in 0 for x to solve. So in standard form, the intercepts is our c value. So remember, domain is a set of all x value for the function. So range is the set of all y value for the functions. So again, domain is the set of all x values for the function. So range is the set of all y values so for the function. So there are sections of the domain. So no, so negative, infinitely and positive. So are any interactions on the range? Yes. So negative, infinitely, and 3. So use the vertex to find the uh, restrictions. So find the lane of symmetry. So when a quadratic function is in standard form, so the formula is y equals ax squared plus bx plus c. So the equation of the lane of symmetry is equals negative b over 2a. So for example, find the line of symmetry of 3 equals 3x squared negative 18 x plus 7. So use the formula x equals 18 over 2 um, 2 and 3. So equals 18 over 6. Why is that answer 6? So 2 times 3 equals 6. So the x is 3. So those the line of the symmetry is x equals 3. So find the vertex. So how to find the vertex? So we all know the line of symmetry always goes through the vertex. So therefore, the line of symmetry given as the x negative coordinate of the vertex. So the find the y is coordinate of the vertex. We need to plug the x value into the original equation. So y equals negative 2x plus 8x negative 3 is step 1. So this is how to find the vertex. So step 1, find the lane of symmetry. So a equals ab negative b over 2a. So equals negative, negative a b is negative 8, so over 2. So the 2a is negative 2, so equals negative 8 over negative 4, so equals 2. So step 3, plug the x value into the original equation to find the y value. So y equals negative 2 times 2 over 2 plus 8 times 2 negative 3. So y equals 2 times 4 plus 8 times 2 negative 8. So y equals negative 8 plus 16 negative 3. Y equals 5. So therefore the vertex is 2 and 5. So graphing quadratics, these are three steps of to graph the parables in standard form. So step 1, find the length of symmetry. So step 2, find the vertex. Step 3, graph the lengths for others points using squares. So graph quadratics. So example, so y equals 2x squared negative 4x negative 1. So step 1, find the length of symmetry. So x equals negative b over 2x equals 4. So over 2 times 2 equals 1. So those the line of symmetry is x equals 1. So graph quadratic. Y equals 2x squared negative 4 times x negative 1. So step 2, find the vertex. So since the x is value of the vertex is given by the lane of symmetry, we need to plug in x equals 1 to find the y negative value of the vertex. So y equals 2 value of 1 squared negative 4 times 1 negative 1 equals negative 3. So those the vertex is 1 and negative 3. So y equals 2 squared negative 1 and negative x negative 1. So step 3, find the latest for other point using square since square the connect the 5 points with a smooth curve. So that is the how to find the length of our point using square root. Square the connect of the 5 points with a smooth curve. So that's all the how to graph the quadratic functions. So another example of a quadratic equation. So the quadratic formula is x equals negative b plus negative square root of b squared negative 4ac over 2a can be used to solve for quadratic function in the form ax squared plus plus bx plus c. The final answer should be reduced the have the radical in the lowest terms. One needs to be careful in reducing the final answer because this step can often be the source of an incorrect answer. So the examples of quadratic equations to solve the x squared plus 6x plus 2 equals 0 by the quadratic formula. So solutions. So value are a equals 1, b equals 6, so c equals 2. So x equals negative b plus negative square root b squared negative 4ac over 2a. So x equals negative 6 plus negative square c squared negative 6 times 2 times 1 times 2, so over 2 times 1. So a x negative equals negative 6 plus negative uh, square root of 36 minus 8 over 2. So x equals negative 6 plus negative square 28, so equal over 2. So therefore a x x equals negative 3 plus square root 7 and x squared equals negative 3 negative square root. So here are factored from the quadratic function. So a quadratic function in the vertex x and form of x f f x equals ax squared plus b squared plus, so where a and b and c is real numbers and a not equal to 0. So and these fractions using integers can be solved by factorings of the applying the properties a b equals 0. So the factoring for of quadratic function is f fx equals a x negative x1 x negative x2, where x1 and x2 are the roots of the quadratic function. Example, solve x squared plus 4x equals 21. So solution. So x squared plus 4x equals 21. A x plus 7 and x negative 3 equals sorry 0. So therefore ax1 equals negative 7 and x squared equals 3. So to complete the factors of the vertex from the standard form, one should be multiply, expand, distribute the factors to converse the standard form of the factors from the quadratic function. X equals a negative b plus negative square root of b squared minus 4x squared over 2. So e is used to determine the roots. So the curvent of the standard form, the vertex from the process called completing the square can be used. So that's all the thing.